Hello everyone, welcome back to See the Concepts. Are ray diagrams confusing you? Don't worry. In this video, we'll learn the easiest rules to draw ray diagrams for spherical mirrors step by step. By the end of this video, you'll be able to draw the diagrams quickly and correctly. So stay tuned and let's begin. Before we start learning the rules, let's first understand the different types of spherical mirrors. There are two types of spherical mirrors. One, concave mirror, also known as a converging mirror, because it converges light rays to a point. Two, convex mirror, also known as a diverging mirror, because it diverges or spreads light rays outward. Now, let's learn the rules to draw ray diagrams for these mirrors step by step. Concave mirror rule 1. A light ray traveling parallel to the principal axis of a concave mirror after reflection passes through the principal focus, F. Let's try to understand this rule with the help of a ray diagram. Here, the incident ray travels parallel to the principal axis. After striking the concave mirror, the reflected ray passes through the principal focus, also called the focus point, F. Now, this is a concave mirror. First, let's draw the principal axis, which is a straight horizontal line passing through the mirror. Next, we mark the important points on the principal axis. Pole, P, the center point of the mirror surface. Focus, F, the point where parallel rays meet after reflection. Center of curvature, C, the center of the sphere of which the mirror is a part. As we know, the radius of curvature, R, is equal to 2f. So, while marking the points on the principal axis, place them in such a way that the distance between pole, P, and focus, F, is equal to the distance between focus, F, and center of curvature, C. After labeling the points, draw a blue ray parallel to the principal axis. This blue ray represents the incident ray traveling toward the concave mirror. After reflection, the light ray changes its direction and passes through the focus, F. This reflected ray shows the first rule of a concave mirror. A ray parallel to the principal axis always passes through the focus after reflection. Here, the red ray represents the reflected ray. I hope you all are clear with Rule 1. Rule 2. A light ray passing through the principal focus, F, of a concave mirror after reflection travels parallel to the principal axis. Let's try to understand this rule with the help of a ray diagram. Again, we have a concave mirror. First, draw the principal axis and mark the pole, P, focus, F, and center of curvature, C. Here, the incident ray passes through the focus, F, before striking the concave mirror. After reflection, the ray travels parallel to the principal axis. When a light ray travels through the focus, F, and strikes the concave mirror, it reflects back parallel to the principal axis. Here, the blue ray represents the incident ray passing through the focus and striking the concave mirror. After reflection, the light ray travels parallel to the principal axis. This reflected ray is indicated by the red ray. Now, let's move on to Rule 3 of the concave mirror. Rule 3. A light ray passing through the center of curvature, C, of a concave mirror, retraces its path after reflection. This happens because the ray strikes the mirror normally, making the angle of incidence equal to 0 degrees. Let's try to understand this rule with the help of a ray diagram. Again, we have a concave mirror. First, draw the principal axis and mark the pole, P, focus, F, and center of curvature, C. Now, draw the blue ray, which represents the incident ray passing through the center of curvature and striking the mirror. After reflection, the ray goes back along the same path because it strikes the mirror normally. These rules were related to the concave mirror. Now, let's start learning about the convex mirror and its ray diagram rules. Rule 1. A light ray traveling parallel to the principal axis of a convex mirror after reflection appears to come from the principal focus, F, behind the mirror. Let's try to understand this rule with the help of a ray diagram. Here, the incident ray travels parallel to the principal axis and strikes the convex mirror. After reflection, the reflected ray diverges outward and appears to come from the focus, F, behind the mirror. Here, we have a convex mirror. First, draw the principal axis and label the important points. Pole, P, focus, F, center of curvature, C. In a convex mirror, both the focus and the center of curvature lie behind the mirror. After labeling, draw the blue ray, traveling parallel to the principal axis toward the convex mirror. After reflection, the ray diverges outward and appears to come from the focus, F, behind the mirror. Rule 2. A light ray directed towards the focus, F, of a convex mirror. After reflection, travels parallel to the principal axis. Again, we have a convex mirror. First, draw the principal axis and mark the pole. P, focus, F, and center of curvature, C. Now, draw the blue ray, which represents the incident ray that appears to be coming from the focus and strikes the convex mirror. After reflection, the ray travels parallel to the principal axis. The reflected ray traveling parallel to the principal axis is indicated by the red ray. Now let's move on to Rule 3 of the convex mirror. Rule 3. A light ray directed towards the center of curvature, C, of a convex mirror. After reflection, retraces its path and appears to come back along the same line. Again, we have a convex mirror. First, draw the principal axis and mark the pole, P, focus, F, and center of curvature, C. Now, draw the blue ray, which represents the incident ray directed towards the center of curvature. After reflection, the light ray moves back along the same path. This happens because the ray is directed towards the center of curvature, C, and strikes the mirror normally. Therefore, the angle of incidence becomes 0 degrees, and the ray retraces the same path after reflection. In this video, I have tried to explain the rules to draw ray diagrams for both types of spherical mirrors, concave mirrors, and convex mirrors. I hope this video helped you understand the concepts clearly. If you still have any doubts, feel free to ask in the comment section. Don't forget to like, share, and subscribe to my YouTube channel, CTheConcepts. Thanks for watching,